we're going to look at more theorems. So this one, we're applying properties of chords in a circle. So chords are those lines that connect any 2 points in a circle. So our first theorem says a diameter of a circle is perpendicular. So remember, the word perpendicular means it creates a right angle. Okay, so perpendicular is important because it's a right angle. If and only if the diameter bisects the chord. So all three of those things have to happen. It's perpendicular, it bisects the chord, and it's a diameter. Okay. So let's look at some examples. Determine whether AB is the diameter of the circle. Explain your reasoning. Okay. AB is here. I'm going to say no. Why? It is not perpendicular, right? That is not a 90-degree angle. That is an 85-degree angle. B, right here is AB. I'm also going to say no. Why? CE is not congruent to CD. Okay, so again, in order for it to be a diameter, those two things are congruent. C, is AB a diameter? Yes. They are perpendicular. And, right, we have these two are the same. CE is congruent to CD. ED. I'm going to say CD. Okay. All right, looking at our second set of examples. Example 2, find the value of x. I don't leave a lot of room for these. That's okay. This is a diameter. This is perpendicular. So then these have to be congruent. So we're going to say x plus 6 equals 3x minus 8. I'm going to get my x's together. 3x minus x is 2x. I'm going to add 8 to both sides. And then I'm going to divide by 2. Okay, so x equals 7. Okay, so that's one of your big takeaways, is both sides. If it says it's perpendicular and it goes to the diameter, then both sides of those are equal. Find the length of OC right here. Okay. Well, OC is part of a diameter because it does go through the center, so I can draw a pretend line. Okay. Meaning these are going to be equal. Since it's 11, this side is 5.5, and this side is 5.5. Okay. Now, in order to find OC, if you look, we have this right triangle here. So we can just use Pythagorean's theorem. So I have x squared plus 5.5 squared equals 6 squared. What is 5.5 squared? I don't have my other calculator up, so I'll use this one. 5 squared is 30.25. Equals 36. I'm going to subtract 30.25. X squared equals 5.75. I can do that. Take the square root. the square root of 5.75 is we'll round to 4. That's fine. All right, find the length of m. So we're finding the length of this whole thing. To start, I am just going to find the length of this part of the right triangle, right? We have this right triangle here. So I have x squared plus 2 squared equals 7 squared. Again, legs, then the hypotenuse. So you have x squared plus 4 equals 49. Subtract 4. X squared equals 45. We're going to take the square root. X equals, I can break down 45. It's 9 times 5. The square root of 9 is 3. Square root 5. Okay. So that means this side is 3 square root 5. This side is also 3 square root 5. That means m equals 3 square root 5 plus 3 square root 5. 3 plus 3 is 6 square root 5. Alright. That is it. Alright. Looking at theorem 2, two minor arcs are congruent if and only if their corresponding chords are congruent. So what is this saying? This is saying arc AB is equal to arc BC if and only if means it goes both ways. Chord AB is equal to chord BC. Okay, so again, this is kind of part of that geometry stuff that we're throwing in. If I know my two arcs are congruent, then I can know my two chords are congruent. This if and only if tells me it also works backwards. If these are congruent, then this is congruent. Okay? Not everything works backwards in this way. The best example that people know is the square and the rectangle thing. If something's a square, then it has to be a rectangle. It is not true that if something's a rectangle, then it has to be a square. Okay, so not everything works backwards. If you see this if and only if, this is shorthand for if and only if. Then both ways works. So let's look at example 5. Solve for x, y. Okay, well, my angles are congruent. This is 3, so this is 3. Done. Easy enough. Part B. We know zy equals 6. And x, I don't know why this is in this section. It's a good question, but I don't know why it's in this section. X, w is 4. We're going to solve for xy. So then, this is 3. We're solving for x. A squared plus b squared equals c squared. 3 squared plus 4 squared equals x squared, right? Because this is the right triangle here. 9 plus 16 equals x squared. 25 equals x squared. So x equals 5. All right. So that's pretty much it for that theorem. This question pretty much tells, they should be easy. Again, I don't know why this was in this section, got misplaced. But that's as easy as those questions are. If you see they're congruent, then you know the other part's congruent as well. All right, looking at theorem 6. Two chords are congruent if and only if they are equidistant from each other. Okay, so what does that tell us? My two chords, so PR is congruent to ST, and if and only if, or you could do an arrow showing that this goes to that and that goes to that. BQ is congruent to QU. So these are congruent if these are congruent. And if these, so these are congruent if these are congruent. And these are congruent if those are congruent. It goes both ways. Okay. So for example 6, we're finding AD. These lines are telling me it's congruent, so since this is 8, this is 8. Ooh. Sorry. Example 7 is actually putting our last theorem, or theorem 4. We're using theorem 4 as well. Right? This is a diameter. It goes straight through the center of my circle, and it's perpendicular. So since this is 3, this is 3. So that means this whole thing is 6. Then these are congruent, so that means this whole thing is 6. So it's using all of these little pieces. That's really it for theorem 6. Most of them will be that simple. All right, theorem 7. If two chords intersect, then the measure of each angle is 1/2 the sum of the measure of its arcs. So what is this actually telling us? So these two chords intersect. One thing to remember is we know these two angles are equal because they're vertical angles. So the measure of both of those, doesn't really matter which one you're trying to find, is 1/2 the sum of the measures of the arcs. So the measure of angle 1 equals 1/2 times I don't know why I did CD first and not AB, but it doesn't matter. Addition is commutative. All right, so you're just adding these together and really dividing by 2. So you're taking the average of those arcs. So let's look at an example. So our angle is going to be x. So x equals 1/2 times 33 plus 131. I'm going to do inside the parentheses first. 64. Then I'm going to multiply those together. 1/2 times 164, or 164 divided by 2 is 82 degrees. Example 9 is a little bit differently. Now, instead of x, right, x is one of my arcs. So I have 115 equals 1/2 times 105 plus x. The first thing I'm going to do to solve for x is get rid of that 1/2. So I'm going to multiply both sides by 2. So you get 230 equals 105 plus x. Then I'm going to subtract 105, which is 125 degrees. And that's it for that theorem. So those are somewhat simple. Theorem 8, if two chords intersect, the product of the lengths of the segments of one chord is equal to the product of the length of the segments of the other chord. Cool. So again, what does that mean? So here's my first chord. I have two segments, AM and MB. If I multiply AM times MB, that is going to be equal to the other chord. So YM times NC. Okay, so the pieces, if I multiply the pieces of each chord, they're going to be equal. So if we look here, it doesn't really matter which chord you start with, so we'll start with this one. 8 times X equals 4 times 18. So we have 8x equals 72 divided by 8, x equals 9. All right, that is it for today. I'll see you guys tomorrow.